How's everyone? I'm a little disappointed that I didn't get the alert to happen during my talk. It happened during the previous one. I just felt like that would have been so appropriate for what we're going to be talking about today. But I do want to talk about code. I'm an engineer at heart. I'm a recovering security person, but I'm an engineer at heart, and I've been obsessed with trying to make efficient software for a long time. Cost is this very interesting metric that I think a lot of us as software engineers forget about. And if you're operating in the cloud, it's a pretty dangerous thing to forget about. So hopefully we have a good conversation about that. We're going to get into some examples. I'm going to try to leave a little time for questions at the end. We'll see what happens. All right. So I said hello. I've been building on AWS for a long time. I've also worked with the other cloud providers. This talk is going to talk a little bit about AWS specifically, but I'm an equal opportunity cloud user. I enjoy using all of the flavors, so don't throw me under the bus for that. I founded CloudZero in 2016 specifically to help empower engineers to get their arms around the cost of their software. I want everyone to be engineering profit at the end of the day. And I'd love to continue the conversation. Please reach out. I mean it. Use my email, send me a note. I would love to continue talking with all of you. So I want to start here. If there's one thing that we all kind of leave this room after we're done talking, having this conversation together, I want us all to remember this statement, that every engineering decision is a buying decision. There's more scrutiny that's going to be directed at the money that you're spending on this event or what you spent on dinner or lunch today than how much money is getting spent in the cloud. Somebody somewhere in accounting is staring at that $50 lunch. Nobody necessarily is staring at the $10,000 that your engineers are spending on cloud computing. And it's hard to kind of fathom this because the CTOs, the CIOs, the CFOs, they used to be in charge of the procurement process, the purchasing process, right? Now today, all of you, if you're engineers, if you've written a line of code that is run in the cloud, you've made a buying decision, right? And you might not have known about the cost of that buying decision. I'd like to change that. So, as luck would have it, the world is talking about things that I think are pretty relevant to what I wanted to talk about today. This actually came out just a couple days ago, and this is exactly where a lot of people are. They're kind of wondering, maybe the cloud was a mistake. Maybe it's a scam. Maybe if we get in there, we're going to discover that we need to get out quick. So let's try to build everything the old way or try to figure out how to operate in a way that doesn't embrace all the features and services that you have. And you end up discovering that, lift and shift, this all seems like a lie. It's super expensive. What the hell is going on? It's a scam. It's a total self-fulfilling prophecy. We need to think differently about this because in my mind, the cloud was really an operating system, a new operating platform, if you will, and we're all writing code today for yesterday's mainframe, not realizing we need to really rewrite this for the cloud if we're going to take maximum advantage of it. This is what we're doing, right? This is how the DevOps movement started, right? It worked fine for us. Let's just throw it over the wall to ops. No problem. Well, now we write code and it works perfectly, and we throw it off for finance to worry about it, right? That's the new challenge for most of us today, living in this economy, but in general, just trying to build great software. I want, at the end of the day, all of us to just build great software. And some people would like to build all that software in the cloud. Well, we'll see how fast that happens, but this guy seems to believe that it's all going to happen at some point. The question is when, right? There's like $4.6 trillion, depending on who you ask, about stuff that's happening out there. It's still running in the data center. The cloud is still, let's not forget, despite all its growth, it's still very early days. We still have a lot to figure out. So if it's going to move to the cloud, it's got to make strong economic sense, but some people are convinced that this isn't going to happen. Some people are actually convinced that it was all a mistake. I happen to think these people are horribly wrong. I live in the cloud, after all. I want to stay there. But this kind of conversation is happening because it hasn't been absolutely abundantly clear to all of us as we sit down to build things that the cloud makes strong economic sense. We have to change that. So I just want you to all know, I've checked the numbers, okay? I'm convinced it does make strong economic sense. I've seen it, but you're gonna have to build differently. You're gonna have to write your code differently. You're gonna have to think about systems design differently. You're not gonna be able to take the thing that worked in the data center and just lift and shift it into the cloud and expect a good outcome. You've got to think differently about it. And today we're gonna actually get really focused in on some very specific lines of code where it would have helped to have thought a little differently. So what is your role? How many people here write software for a living? Fantastic. How many people write software in the cloud for a living? All right, we're all in the right place. So cost efficiency today, it often reflects system quality. A well-architected system is a cost-effective system. One line of code can kind of come down to whether or not the company you're working for is profitable or not. And we have a challenge that we're going to figure out together during this talk about what is the best way to measure cost efficiency. But before we get into all that, I just want to get into the code. I'm an engineer at heart, after all. Now, disclaimer for the stuff that I'm going to show you. These are all real examples, but I had to protect the witnesses, so to speak, right? So it's all been normalized and translated into Python. It's all been kind of rewritten to protect the innocent, but these are all things that resulted in people spending way more money than they should have with just a few lines of code. All right. So I'm going to start with my favorite example, and I've got 5 examples for you. Here's the situation. How many people just played the rest of the lyrics in their head for that? No? Okay. Parents went away for a week's vacation? No? Okay, all right, all right. AWS Lambda function with an average monthly cost of $628. CloudWatch, average monthly cost of $31,000. What's happening there? We just heard in the previous conversation about CloudWatch costing way more than the actual evoke of a Lambda function. I don't know how many people have experienced this in their lives, but this happens all the time. For this particular example that I'm going to show you, this single function, since deployment, it cost $1.1 million in writing this data. And what was the cause of it? Was it engineering necessarily jumping in there? Well, it was a combination of 2 things. Code that shouldn't necessarily have left the building, something that did something important, and a well-intentioned debug line that when the ops team turned on debug logging and didn't think much about it, echoed everything into CloudWatch, right? And because ops is sometimes disconnected from dev, there's, we'd love to think that DevOps is always working together, but nobody kind of knew about it. And they just kind of assumed that it worked that way. And it ran for a long time, $1.1 million. So what's the fix for this, right? This one's pretty simple. Start us out easy. We know that's the problem. That's a great thing if I'm writing some sample code on my desktop. But the fix is just delete this. We don't need this. The developer, if they're building this code, when they're testing it out, it's great and helpful at that time. But when you deploy it, don't put this in there. It's like a vulnerability. It's a bomb waiting to go off. So the fix is to delete it. All right, I want to give another example. Next situation. We've got an MVP that found its way into production. Product, years later, now is creating billions of API requests to S3. And it's grown nice and slow so that nobody noticed the whole time along. The total cost of this code over just 1 year is $1.3 million. Does anybody want to spot some of the challenges in this code? There's many, but there's a few. This worked as an MVP perfectly. In fact, it's great. Get an idea, put it on paper, make it happen, deliver it. But why are these things inside the for loop? Why on earth are we calling out to the S3 APIs while this is running out? We could actually pull all this stuff out of there and easily cache or capture this information. But the problem is this code works, right? And when it got deployed, it worked just fine. And it wasn't until years later, when it was up to scale, that it started to cost that $1.1 million. And we also got a little detail here. Maybe I shouldn't be passing these files to do further processing off to my next function. So what's the fix for this one? Well, let's pull that outside of the for loop. By the way, bonus points. Anybody know what reticulating a spline is? Come on. Okay, thank you. We'll talk about SimCity later, all right? So pull this stuff outside of the for loop, calculate this stuff or download this stuff in advance. Do it once instead of the million times that we're running inside of this function. And instead of passing just some pointers to the files to go look up later, pass the actual data. Use it once. Simple stuff, right? But again, we've all done this where we got the code working, it worked as a prototype, and then it snuck out the door and we never thought about it ever again. API calls cost money. And a lot of times, S3, the API calls might cost more than the storage. So this next example is one of my favorites. I don't actually know how much this costs to run, but I do know that it is certainly an expensive mistake that I've made before, that I've seen others make. And when I learned about it from Quadra, I just had to include it in the examples. So this is an example of how a developer was asked to add something very simple. You know what, this record that we're writing in DynamoDB, it doesn't have a timestamp. We'd like to know when it was actually written. Why don't you just add that field? It should be super, super easy. Code change that takes seconds, somebody tested it, deployed it, it's up and running. Look at the bill shortly there later. DynamoDB costs have just gone up 2x. So this one's a little harder to spot. I'll give you a few seconds. Does anybody see why adding that timestamp line, that single line, made DynamoDB cost 2 times as much as it did before? Any guesses? Raise your hand. You don't have to yell it out, but if you have a guess, I just want to know. No? All right. DynamoDB charges in 1K elements for writes. It's 1,000 bytes being written, but we added timestamp. That's an attribute. That's 9 bytes. We added a timestamp in ISO format. That's 32 bytes. I'm 141 bytes, 2x the cost, 1 line of code. Pretty hard to spot that one, right? We have to think differently about how the data is flowing across the line. More importantly, how that affects our costs. So what's the fix for this one? Well, actually, we should do 2 things. We should reduce the size of the attribute name. As Quadra mentioned to me earlier, it makes it more aerodynamic when it flies through the wire. It's a very important property of the TCP IP protocol. So make that a TS instead of timestamp. Let's shave off a few bytes there. Let's reformat our timestamp so that we're down to 20 bytes. Hey, good news. We got 2 bytes to spare. We're under the wire. Writes are back to where they needed to be. 1 line of code, 2x the cost, right? All right. Now let's not forget about infrastructure as code. Terraform and CloudFormation. They're guilty here too. Everything is code these days. So we've got a Terraform template. It's creating auto-scaling groups. They scale up clusters that have hundreds and maybe even thousands of EC2 instances at a time. Someone designed the system so that it refreshes the instances every 24 hours. I don't know, maybe they had a memory leak and they thought that was a good way to fix that. But it's refreshing those instances every 24 hours. And then somebody in security was worried that the data was maybe important. So let's not delete the EBS volumes. Somebody would go look at that, right? Nope, this system ran for about a year, slowly generating cost. At the end of that year, $1.1 million went out the door. This is a little bit verbose, as is all infrastructure as code. But there's 2 lines in here that are the culprit that caused this. Somebody turned off delete on termination, and somebody set the max instance lifetime to that refresh time. It's in 2 different files too, so they're not even going to be looking at the same thing necessarily. And those 2 changes meant that every time that EC2 instance spun up and it created EBS volume, it left it around after it terminated and refreshed itself. And over time, if this is max size of 1,000, and in this environment it was somewhere around 300 to 600 EC2 instances at any given moment, That adds up pretty quickly. And over a year, that adds up to just over $1 million. The fix to this one's a little more complicated. This one, you have to change your processes. You have to think a little bit about how your team is working when they put these things in place. If you're going to create resources, you should always also ask the question, how are we going to get rid of it as well? And this applies to a lot of things in the cloud, not just to cost. A lot of us have spent the last couple of years thinking about how to scale up, but we don't think enough about how to scale down. Scaling down is way harder, and it's way more important. And it also can save your business. If you were a travel company during COVID, the ones that really survived were the ones who knew how to scale down. I hear amazing things, by the way, of the team at Expedia. They really knocked that one out of the park. So beware of well-intentioned infrastructure as code, particularly if you've got requirements coming in from different teams. All right, fifth example. I left the best for last. We love content delivery CDNs, right? That make all of our stuff go faster. We can move content to our customers better. Well, there's a particular company that had 2.3 million devices out there, all running across the world. And the change was deployed. And it got deployed to all those devices. And after about 14 hours, the impact of that payload started to become known. It reached a steady state of about $4.5 thousand, $4,500 an hour. It took them about 6 days to resolve it. They went through pretty exhaustive testing. The total cost of that incident was $648,000. If that had continued to run for a year without anyone noticing, and I'll explain why they may not have even noticed, it would have been $39 million. Somebody somewhere would have been begging for that money back, I'm sure. And hopefully somebody would have seen it in finance after the first month. But that would have been after the first month. 6 days, $648,000. That's a pretty painful bug. And from their point of view, this was a success story because they found this within 6 days. Normally, it would have taken weeks or months. Let's just say that's a really messed up kind of barometer for what's a success story, unfortunately. So, what's the code? Well, it looks something like this. They had a kind of a well-intentioned update code that was probably written by an intern a long time ago, and they updated it because it used to call once a day, and it would download and it would compare this hash and like, hey, that sounds like a bad idea. Why don't we download some metadata so that we don't necessarily need to do this? It was actually designed to lower costs. They rolled it out. They expect everything to go in the right direction. They weren't quite certain what happened next, and then suddenly they discovered it wasn't quite working the way they expected. How many people can spot the bug despite the other issues with this code, but how many people can spot the bug in this code? It's a single character. It's just one single character. Because with that one single character, it meant that this code flipped to the more expensive path, and at the same time, they moved this up to calling up every hour instead of every day or two, and they were off to the races. And CloudFront, by the way, was happy that they showed up. It did a great job. It scaled up. It delivered that content. Nobody was harmed. Everybody was happy. The data is flowing. People might have been wondering why all this data is flowing around their home networks for these devices, but it worked. And the operations teams and the monitoring tools behind the scenes, no errors, nothing to alert them. Datadog's not telling them anything's wrong, because CloudFront's happily swallowing the traffic. Everything's working. The only indicator of this is that they are now spending $4,500 an hour that they weren't spending before. Single character. So the fix for this one really is they went back and rethought this whole thing. It wasn't just let's change one character now. They did a quick fix and then they went back and thought more deeply about it, because this is a pretty important aspect of their product. But it's one of those things that is very easy to get in the mode of building out and doing, and when you operate not quite at scale, and then you bring it up to scale, some of these things sneak in. This one was a pretty painful single character bug that would have resulted in a $39 million bill. All right, so what have we learned from all this, right? Well, storage is still cheap. We should really still be thinking about storage as being pretty cheap, but calling APIs, that costs money. It's always gonna cost money. In fact, you should just accept that anything you do in the cloud costs money. It might not be a lot, it might be a few pennies, it might be a few fractions of pennies, but it costs money, and you should think about that before you call an API. We all have practically infinite scale now. I have not yet found infinite wallet. We have a constraint that no one's figured out. If anybody figures out infinite wallet, let me know. We'll keep it secret. It can just be between us. We don't want to upset the world economy, but it'll be fine. We'll buy an island. We'll go live there. It'll be great. And CDNs, they're always going to be great at eating traffic and eating your money. So what's the important takeaway from this? Is it that we should now layer one more thing on top of all of us to do all day long? I do spend some time thinking about this, but gosh, this sounds pretty painful. I guess we're just going to have to get all of our engineers agonizing over their costs of their code. They've got plenty of time to do all this, right? This is as true as it ever was, right? Premature optimization is always going to be evil, whether it's performance or it's cost. The first thing that we have to figure out as engineers often is, can this damn thing even run? Will it even work? Can I even achieve this problem? Because all of these examples that I've shared with you, they're not actually problems until you get to scale. They're not actually problems unless you're successful. They're not actually issues that you should even care about unless you might be onto something with the product or the service that you're building. So, in my opinion, cloud engineers, they should think about these questions, but they should do it iteratively over time and not all at once. When you first answer that question, can it even be done? Then remember you work on a team. Is this the right way to do it as a team? What happens if this thing becomes popular? Maybe that's the point where you should start thinking about it. And then how much money should this cost to run? Now, I don't know about you, but when I first started building some of the first systems in the cloud, I had no idea how much any of this stuff should cost. In fact, when I went to my CFO and said I wanted to use AWS for a project, he said, Eric, you can do whatever you want, but you have a budget of $3,000. Don't go spend it all at once. Now, that was a long time ago, and we were a little fearful. But I said, I don't know, I want to play with the cool toys. And we used that $3,000 to build a pretty amazing system that we then sold for $800,000. And the only reason we did that was because I was suddenly obsessed with trying to maximize my return on that investment. Now, is that for everyone? Do we want to give engineers a budget? I think actually we want to give engineers something a little bit more powerful, not a number. Because oftentimes the costs of operating in the cloud equal buying a Lamborghini every single day, which seems completely abstract and bizarre. Instead, let's focus on efficiency. And for that, I have a concept called the cloud efficiency rate that I want to share with you. And it's really simple. It's designed to be simple. Cloud efficiency rate can really guide you into thinking, when is it time to start prematurely, or not prematurely, when is it time to start actually optimizing and not do it too premature? And you calculate this by taking your revenue minus your cloud costs over your revenue. That gives you a percentage. Simple example. You're making $100 million as a company. Your cloud costs are $20 million. You're spending 20 cents per dollar revenue. Your cloud efficiency rate is 80%. That's awesome. But you don't necessarily need to get there right out of the gate. A cloud efficiency rate is something that we should think of as a non-functional requirement. It's something that for any cloud project, you should have your product managers, your product people, the business, somebody helping guide you to understand what is the desired cloud efficiency rate, and at what point in the life cycle of this application should it be? What should it be as you kind of grow and build that application? R&D, trying to figure out if it just works. It could be negative. It should be negative. If you're making money before you even ship the product, something's wrong. Or maybe that's an excellent business model, I don't know. Once you get to MVP, try to break even. This is what I would recommend. Try to break even. Have a low CR, it doesn't matter, 0 to 25%. Get to product market fit. People are actually telling you that they want to buy your product, and it looks like, well, wait a second, what happens if this thing actually becomes popular? Well, let's try to get to 25 to 50%. We're now scaling. It is, in fact, popular. People are running around buying my stuff. I need to have a demonstrable path to getting to healthy margins. Let's get to 50 to 80%. And once I'm at steady state, if I want to truly have a healthy business, if I want to be a profit engineer for my organization and not a drag on that, getting to 80% is a really good guide. And the cloud efficiency rate takes this abstract, annoying thing, dollars, that none of us really want to understand or can understand, and turns it into something that's a target that we can set in motion for us. And it can be across our entire cloud platform, or it can be specific to an individual customer, or feature, or service, or anything new that I'm trying to ship. So as a rule of thumb, I would recommend you target a CR of about 80%. So I have some final thoughts on this. When I was doing the kind of homework for what I wanted to talk about here, some people said that Sir Tony Hoare here was responsible for the premature optimization quote, but Knuth wrote it in his paper. He said he was quoting this guy. I don't know, it got confusing, but this blew me away when I did my research. Because this gentleman had me beat by years. And I was playing in the wrong category. He had $1 billion mistake. I'm in the small leagues. I got to up my game. And he gave this talk at QCon years ago in London. And I invite you all to watch it because it's very interesting. But he talked about inventing the null reference in 1965, and because of his early sin, he says this has probably cost billions of dollars in the world economy. And he's probably right. And one thing we all know as engineers is that over time, our code takes on a life of its own. It falls in other people's hands. It moves on, and we lose sight of it. And those things that cost a few pennies while we were writing that code, testing it out on our laptop, and now deployed and running somewhere, it could just be $1.1 million per year to run that. So when you get back to your laptop or your computer and take a peek at some of that stuff, think about that. Hopefully you don't have a kind of gasped reaction. But if you do find something, it'll save you from giving a talk in 10 years about billion-dollar lines of code. All right, so remember I wanted everyone to leave with this idea in their head. Every engineering is a buying decision. You all are making the buying decisions. It's a very powerful role that you have in the organization. It is, in this economy, in this world now, in this cloud-driven world, it is, in my opinion, the most important role. You all have the power, more powerful than the CFO. So I want to thank you all for coming. Please give me some feedback, good, bad, ugly. I want to hear it. I want to evolve this idea, and I hope to come out and talk with all of you again about this topic. Thank you very much.
So this one's probably a little bit niche, but I work for a nonprofit, so calculating the efficiency rate is a little bit tricky because we don't actually have revenue or products that we're selling. What would you use to kind of adjust this efficiency rate formula and whatnot to try and calculate that when you don't actually have a revenue stream?
So I would substitute, as a nonprofit, you have a number in your bank account, a budget somewhere. I would substitute that in that case. There's another variant of this as well. If you're at a government organization, you actually don't want to come in under budget. So you have to flip the equation around sometimes and actually hit your budget perfectly. So those are two scenarios where you have to think a little bit differently if you're not in the business of generating revenue. But I would take your budget, or I would take your fundraising goal, if you want to be projecting out something or forecasting it out a little bit, and say, well, we intend to kind of meet these points of view, and this is what we're going to allocate for our cloud budget, and then set that as how you would calculate that rate. But it burns down a little bit differently. So I'd love to talk with you more about it and kind of come up with an equation for that specifically, actually. I think there's a couple things we could do to the mix to make it perfect. Great question, though.
Hi, well, nice to thank you. Real life question. There's a huge system, small team of engineers that branching out some functionality in cloud. Now, they facing cost questions, even more. So what would you suggest? Like, it's so hard to calculate it right, based on your example because it's part of the system. At the same time, where do you say they can find guidance in that regard?
So let me make sure I understood the question right. You're saying there's a part of the system that's representative of the costs, and the challenges.
Part of the system being migrated to the cloud.
Got it. Oh, so it hasn't been migrated yet, and you're thinking about it. Got it. In the span of migrations, it's really the same thing. You're moving from one computing environment to another. You're spending money, so hopefully you have a good kind of understanding of what your on-prem, operational costs are for that particular component. If you don't, you're going to have to do some back of the envelope math. You should have that in place already if you're considering a move, because it's going to really help you kind of judge if you were successful or not, honestly, at the end of the day. So let's just assume that you've got some data there. That's going to become your baseline. And then you're going to need to apply that same thing to the equation. Right? What was your cloud efficiency, or what was your data center efficiency rate, essentially? The numbers might not be one-to-one. There's other things you're going to have to probably incorporate into that. On-prem, cooling, power, headcount, people, time, those are other kinds of parts that will contribute to the COGS. I would include those as well in the calculation, so you get something that looks a little bit more realistic.